We're going to be talking about the problem number 93, section 6.1. I'm looking at your textbook, Pre-Calculus 7th edition by James Stewart. Okay. Problem number 93 is telling us that we have a conical cup that is made from a circular piece of paper with radius 6 centimeter by cutting out the sector and joining the edges. So first of all, this is 6.1, number 93. So what does that mean? So we have something like this circular piece of paper, and the radius of this circle is 6 centimeter, and I'm going to go ahead and cut a sector from it such that the theta left is 5 pi over 3. So we know that this is, let's see, let me keep it this way. Okay, so one revolution is 2 pi. I just cut, I needed to have 5 pi over 3 left, so I had to cut pi over 3. Okay. Part A, so this right here is my theta. Let me do a, so here's what we have. So from here to here, so this radius we said is 6 centimeter, and this theta right here, the leftover that I did not cut, is 5 pi over 3. 5 pi over 3. So how much did I cut in here? Pi over 3. Okay, so now if we go ahead and try to make a cone out of this, if I just say, if I attach this right here, I have some Scotch tape. So we are making a cone. I think this is good enough. Making a cone out of this by just joining those two cut edges. Part A of this question is asking, what is the circumference of opening of the cut? So part A is asking for circumference. And by the way, I'm in page 481. Page 481, number 93. So we are looking, we are looking for this circumference, okay? What is it, remember that we also learned the circumference for this problem is the same as this linear distance right here, that in this section we call that S, and that equals to R theta. So C or S equals to radiuses, which is 6 times theta times 5 pi over 3. And 3 and 6 cancel out to 2. 2 times 5 is 10. So I have 10 pi centimeter, which is approximately 31.4 centimeter. Okay. Part B of this question is asking, B is find the radius of the opening. Find the radius of the opening. Okay. So I'm looking for from the center, the radius. This is the opening. This is the opening. And so I'm looking for the radius of that. We know that we know that circumference of any circular shape or any circle is 2 pi r. And so I can solve for r, and I can divide both sides by 2 pi and say that r equals to circumference divided by 2 pi. And that equals circumference, we just found it to be 10 pi. So 10 pi in part A, we found that divided by 2 pi. So cancel the pi. So I have 5, and the unit was centimeter. Part C of this question is asking, find the height of the cup. Find the height of the cup. So if I do this, my cone in here, and we found, so this is the radius, and this right here is the height. We want to find that height. Okay. So now we can use the Pythagoras. We know that this side right here is 6. Okay. How do we know that? From the beginning of the, because that was the radius. That was the radius of the original, circle. And we found out the radius of this cone is 5 right here. So this radius is 5. So I'm going to say that h squared equals to 6 to the second minus 5 to the second uses Pythagoras theorem. So h equals square root of 36 minus 25, which equals to square root of 11. Okay, and so that's centimeter again. And finally, the last part, yes, there is a part D. Find the volume of the cup. Part D. Volume of the cup. Okay, so the shape is it's a cone. So I'm going to say that volume equals to 1/3 pi r cubed times h. And so, r squared, sorry about that, r squared, because the 1/3, yeah, pi r squared h. So I have this equals to 1/3 pi 5 squared times square root of 11 times square root of 11, and that approximately equals, so I have 1/3 times pi times 25 times root 11, and that gives me 86.829 ... So let's say that 86.8 centimeter cubed or cubic centimeter. I hope you like this example. Once again, from your own textbook. Authors are James Stewart, Redman, and Watson. Have a nice day.